right, everybody, welcome to this latest virtual weather and climate office hour. In today's session, I wanted to cover a slightly broader range of topics, thinking about recent weather in California, which has been unsettled, maybe a bit more so than had previously been anticipated, with some interesting phenomena to talk about. Nothing too dramatic, but interesting nonetheless. Talk a little bit more about the broader water picture right now in California and the western U.S., including late season snowpack, what that looks like, and how this all relates to drought and wildfire risk or lack thereof, as the case may be locally. And then I did also want to talk a little bit more about what's going on in the federal government, offer a few updates with what's going on there. This will not be a session primarily devoted to that, but I did want to spend 5 to 10 minutes at the end discussing that today. And then, as always, I'll be keeping an eye on the live chat where folks can ask questions whenever they like, and I will primarily focus on answering them at the end of the session. So hopefully containing it within the hour today, hopefully not a marathon multi-hour session. Been more than a few of those this year, but today's I'm going to try and keep it pretty tight to the hour. So a couple other program reminders. One is, of course, that this channel is sponsored by Reask, a climate tech company that is helping companies to rethink extreme weather risk in a warming world. And the other one, a slightly newer announcement, is that it's now possible, if you are so inclined and able, to support the Weather West channel through a membership, through which you get a few decidedly modest perks, including some custom weather emojis and access to a private cloud photo stream. Those posts are visible to folks who have a membership. Otherwise, everything else remains fully available to everybody, because I think that's an important part of my philosophy and my role. But if you are so inclined, you don't really get any access to the core content any differently than anybody else. But there are a couple of other little fun things on the margin. But mostly it's just a way of supporting the channel, and thanks very much to those who have done so. Okay, so what I really want to focus on today first is recent weather in California. And that is to say that it hasn't been a particularly dramatic period for California weather over the past several weeks, a month or so. There have been some unsettled conditions. It has rained at various places, mostly minimally, but locally quite a bit. There were some isolated but very heavy downpours on a couple of occasions over the past couple of weeks. Maybe more notably is the Sierra Nevada snowfall that occurred. There was widespread snowfall. Really not that unusual for April in the High Sierra, but it is relatively late in the season, and it also came following a fairly long and relatively warmer period, so that always catches some folks by surprise. And there might be a little bit more of that to come, with another cold low-pressure system making it into California this weekend, bringing, perhaps most obviously for most people, much colder temperatures once again, and probably a significant round of Sierra Nevada snow redoubling, sort of what we saw last week. So 2 weekends in a row with significant late season Sierra snowfall, and probably at least scattered showers elsewhere. It doesn't look like a particularly major precipitation event at lower elevations. In fact, a lot of places might stay mostly or completely dry, absent a bit of drizzle. But again, just like last week, there could be some isolated pockets that get those heavier convective showers, those isolated thunderstorms that could see a pretty heavy downpour out of all of this. So your mileage may vary, literally, depending on where you are with all of that. I'll get into the details a little bit more in a moment, show some graphics. But the other piece I wanted to show, and actually I do want to show this, so I'm going to start sharing my screen in a moment, is where we are with water and snowpack in the western U.S. Right now. So I'm going to start with the thing that I actually think is the least representative of everything that we're seeing today, and the reason for that I think will become clear in a moment. So I'm going to switch over to sharing sharing my screen here, you're going to see well, you should see what I see. Let's see. Maybe, maybe not. There have been a number of operating system updates that have keep messing up my OBS preferences. So just bear with me for a moment as I re-add the screen capture here. Okay, I am not sure why it's not letting me do this. Alright, bear with me for just a moment here. I'm trying to figure out why the screen capture is not working. Maybe this is why. Let's see here. Oh, maybe this is it. Maybe. Fingers crossed. No. Okay, Okay, well, I may have to go without sharing the screen if I can't figure this out. Let me see here. I'm just going to remove all of these and then try re-adding them from scratch. Sometimes that's the classic IT solution. Delete it all, turn it off, restart it. It's hard to restart in the middle here. Whoops, that's my camera. Screen capture here. Okay, display. All right. That's not what you want, though. That's just the... All right, well... I just cannot quite figure out why that's the case. All right, just give me one moment here. If you'll bear with me, I have to quickly Google something while I'm live. Okay. Just verifying one last thing here. All right, well, if anybody in the audience has an obvious solution for the OBS screen capture just showing a blank black screen, let me know. Otherwise, I'm going to describe some of what I was going to talk about without the graphics, which I know is not ideal, but I just cannot figure out why this is not working. I have done this many times before, and once again, the resetting of the operating system seems to have erased all of the settings. One thing I may try, one last thing I may try is to quickly log off and return to this. Hopefully I don't end the stream. Let me just see if I can do that for a moment. All right, here. Okay, I'm not sure that that's actually an option with YouTube. Okay. Sorry, folks. This is just one of those things that if I were a little savvier. So the problem is, folks, if I stop and restart the stream, we'll lose, it won't be the same link. We'll have to re-advertise the link, and that is probably more trouble than it's worth. So if I can't figure this out in the next 1 to 2 minutes, I'm just going to go ahead without showing graphics, which again, I know is not ideal, but I'm doing the best I can without further troubleshooting here. Just give me 1 more minute here. Oh, maybe it's not selecting the right display potentially. So let me see if I can somehow it is not seeing that I have a display at all, which is odd. Okay, folks, I'm giving up on the screen sharing for today. It's just not gonna happen. Okay, so what I wanted to talk about in terms of the water is, fortunately, I've looked at everything in advance, so I can describe most of what's important. Is that if you look, for example, at the California Department of Water of Resources website, you'll see a current estimate of water levels in all of California's major reservoirs. And the interesting thing about this year relative to recent years is that every single reservoir in the California system is near or above typical storage levels for the date. And again, today's date is the 29th, so we're talking about late April. And that is a testament to, in part, the resilience of the water storage system, but also the fact that we have, in fact, had 2 to 3 good or very good water years in a row in Northern California, and also not this year, but the previous 2 years were also good in Southern California. So there was a lot of rain and snow that was able to accumulate and then become runoff that was stored in these reservoirs. So reservoir-wise, water storage-wise, urban and agricultural water-wise, we're in very good shape for this year. Really, from a meteorological and water supply perspective, that isn't a concern. So there really isn't going to be a widespread water deficit in any part of California that is sourced by major reservoirs, because those reservoirs have a lot of water in them, and most of them are continuing to receive runoff for a while still with the water that's still coming into the system. But some folks have taken that to mean that, of course, that there are no water problems at all and that there is no drought in California or the Southwest. And that, of course, is not the case, because there is, in fact, a rather severe drought that has been ongoing across much of the Southwest now for decades. This is the so-called Colorado River Basin mega drought. And although we don't talk about the Colorado River as much in California as some of the other southwestern states, Southern California does receive a portion of its water from the Colorado River Basin, and southeastern California, the deserts, is technically part of the lower Colorado River watershed. And the drought right now actually does extend all the way across all of Southern California and even up into some parts of Central California, the southern fringes of Central California, if you will. And there are really two different droughts. If you were to look at the drought monitor map, which I had so nicely queued up on screen, and I can see it in front of me right now, but OBS is refusing to display Windows applications or anything else for reasons unknown, is that there is a broad drought extending essentially from New Mexico all the way to Southern California and northward into south central Nevada, Utah, and southwestern Colorado. So it's a big region encompassing the Four Corners region and all of the lower Colorado River Basin and some of the upper, as well as portions of Southern California that are not part of the Colorado Basin. So this includes Los Angeles and San Diego and Santa Barbara. Now, what's interesting is even in Southern California, as I've talked about earlier this year in the context of the wildfires, reservoir levels are fine and dandy in Southern California. In fact, they're generally above average, despite this year being an exceptionally low precipitation winter in Southern California. Again, how can that possibly be? Well, it's a testament to a fairly well-functioning water supply system, which is designed to, and in this case, is buffering against water supply shocks. So if we were completely dependent on the water that fell from the sky month by month and season by season, Southern California could be in bad shape right now because not a whole lot of water fell from the sky this year. But of course, that would be a dangerous way to run a major metropolitan area that requires a lot of water, and so there is been historically a huge investment in these water supply, water conveyance, water storage systems that their primary purpose is to buffer against natural scarcity. Well, scarcity, natural or otherwise. And that's exactly what's happening right now. So despite the fact this was a terrible water year in Southern California, many places ended up seeing, and this was the other map that I would have shown you, 50% or less of the average amount of rain in many regions in Southern California. So that's quite a large deficit. Not true, of course, in Northern California, where some parts of the state north of Interstate 80 actually saw a very exceptionally wet year. But the carryover from recent years in the reservoirs is what's going to get California through this year pretty easy in terms of water supply. There really aren't any foreseeable problems there. But here is where I wanted to make a point about why water supply does not tell us everything we need to know about what's going on. First of all, it doesn't tell us what happened meteorologically this year, where Southern California saw a very dry winter with very low precipitation. Of course, it hadn't really rained at all as of mid-January when the catastrophic wildfires in LA occurred. It did eventually rain, in some cases fairly heavily thereafter, but only on a few occasions. And so, despite additional recent rainfall, most of Southern California remains well below average for the season to date. And also, over the past 30 days, all of Central and Southern California has also seen below average precipitation, which is in line with predictions from a couple of weeks ago, or several weeks ago, that much of April and parts of May would probably see below average precipitation in Southern California, and that has now happened, despite the fact that there could be some additional showers. In general, it was also warmer than average over the past 30 to 60 days across most of California, although this is less true. In fact, it is not true at the immediate coast. So once again, we have a situation where the past 30 to 60 days were warmer than average inland, including in the Southern Sierra and the Central Sierra, where snowpack loss was very rapid in recent weeks. In fact, despite peaking around 100% of average snowpack earlier in the season around April 1st, the Southern Sierra is now down to only 50% of average for the calendar date, so that does account for the usual amount of melting. That's largely because it's been unusually dry and unusually warm in the Southern Sierra in recent weeks. But also, the fact that the coast has not been particularly warm over the past couple of months. In fact, LA area, San Diego, San Francisco, North Bay have been rather cool relative to the recent historical average for this time of year, despite the inland areas being warmer. And that's a bit different than we had predicted for the past couple of months, so that's interesting. I wrote a blog post yesterday on the Weather West blog, and for those interested, I encourage you to check it out directly, especially because I can't show the images right now. But aside from talking about the upcoming weather, I also emphasize that there is a very different pattern of historical warming that we see in April and May relative to the core summer months of June through August. And that is to say that California is definitely warmer than it used to be, even in April and May, although the rate of warming has been slower at this time of year than at other times of year. But noticeably, a lot of that warming happened prior to the mid-1980s, and the rate of warming in April and May, specifically in these calendar months across California on an average basis, has been kind of minimal. And what warming has occurred since the mid-80s has come not from more extremely warm April and May periods, but from losing the unusually cold April and May periods. So the warmest April and May periods have been essentially just as warm for the past 30 to 35 years, or even longer, potentially 40 years. The coolest April and May periods have continued to get warmer in that interval, which mainly explains why April and May still have been somewhat warmer overall. But that's very different than the warming pattern we see in California at other times of year, most notably summer, where both average temperatures and the hottest summers on a statewide basis have become dramatically hotter very quickly. In fact, over half of the hottest 10 summers on record occurred just in the past 10 years. That is the opposite of what you'd expect with a statistically random sample. So we've seen record-breaking warmth 5 out of the 10 last summers, and that is coming not just from some strange skew in the distribution, but indeed the average temperatures are warmer, and the hottest temperatures have also been similarly warming at a similar rate as the average temperatures in summer, which is different than what we see in spring. So it is interesting that it has been recently kind of difficult to get extremely warm springs in California. That is probably fortunate from the perspective of snowmelt in particular. And I don't necessarily think we can expect that to continue indefinitely, but it certainly has been a fortuitous turn of events relative to the alternative of seeing rapid warming in spring and much earlier snowmelt and earlier starts to the fire season. We've seen plenty of very severe fire seasons in California in recent years and extremely severe wildfires individually, but this not so much because the season has lengthened greatly on the front end in spring. It has more to do with the summer being hotter and drier and the fall in particular being hotter and drier when those dry conditions increasingly overlap with those offshore wind conditions. And so, interestingly, at least in this part of the world, spring has been a bit of a reprieve in recent decades compared to other times of year. That's not what climate models suggest will continue in the future. So there's an interesting question of, is this something that they've gotten wrong, or is this just sort of a random wiggle of variability that is sort of happening by random chance, and eventually that long-term trend towards significantly warmer and drier springs will manifest as they had long predicted? We don't know yet. And this may, in fact, have to do with some of the other bigger uncertainties regarding, as I've talked about in the past, what's happening with El Nino, big El Ninos in a warming climate, for example. So far, something different than what climate models had suggested would happen at this point. So we're still grappling. And when folks ask, well, what are some of the big questions remaining in climate science? If we know that it's warming, we know why it's warming, we know roughly how fast it's warming. Well, it's stuff like that. Regional climate change, regional hydroclimate, and then even global scale things like if climate models are predicting a large increase in the most extreme El Nino events, why have we not seen that yet at this point? We don't know if that's because the models are wrong about something relatively important, or whether that's actually they're still right, but we just sort of randomly are off in our own unlikely but possible excursion into the distribution of potential outcomes, and that eventually, statistically, we will come back to what models suggested we would be doing. This is a perennial question in predictive science, especially forward in time predictive science, in a context where initial condition uncertainty is very high. In other words, um, there is a lot of natural variability in the climate system in addition to the human-caused trends that we know are occurring. And sometimes these interact in ways that are difficult to disentangle and to fully understand. And this is where the rubber meets the road. This is where a lot of the active and ongoing climate research is today. And it's one of the reasons why we need ongoing climate research today, which is that, okay, it's great to know that the Earth is warming and why and roughly how much, but does that actually help us adapt to that warming climate locally and regionally? In and of itself, not really. The global mean temperature is not a very useful number if you live in a particular place in the world, which everybody does. So what we need is more information about the details, about regional climate, regional hydroclimate, and the dynamics of the change that we're observing relative to what we will observe moving forward. All of that is still a very active area of scientific inquiry, and one of the main things that's focused on these days in trying to understand what's coming next. But anyway, I thought that was an interesting aside. You can see some of the data there. I pulled it up and put it into the most recent Weather West blog post. But it does look like, again, we've had another April, at least April, that was not extraordinarily warm in California, and that is in keeping with recent trends, where April's and to a certain extent, at least the first half of May, have not warmed as much as the rest of the year in California. Now, a very different thing is true once we get into June through September or October, and indeed this year in particular, that is again what seasonal climate projections suggest is likely, which is that the anomalous warmth will become far more anomalous as we get towards June and beyond. So then again, they did suggest that April and May would be significantly warmer than average, and so far they're not necessarily tracking in that direction. The other piece I wanted to emphasize from that blog post is the notion of shifting baseline syndrome, as others have called it, and the declining remarkability of anomalous temperatures, which is a kind of a lot of big words. Really, it's just to say that because the world and because California is warmer than it used to be on a consistent basis, that our perception of how unusual it is to be a given temperature is out of alignment with how unusual it actually is in the broader context of the last 100 years or so. So because California has warmed as much as several degrees at certain times of year, a several degree anomaly on a monthly timescale would have been a pretty big deal 100 years ago, but now it's just ordinary. And so when folks say, oh my God, it's so cold, I've never experienced it being this cold in California, well, the perennial joke is that so many people in California come from elsewhere that this is almost always going to be the case if you've only been here for a couple of years and it's a little bit chilly. But the broader truth here, I think, is even if you have been here for decades, you've gotten used to the conditions over that period of time that you've been here over decades. And so the fact that the last 30 or 40 years is much warmer than the 30 or 40 years before that, you almost zero that out in your mind, imagining leveling a scale, tearing a scale. If you've ever needed to weigh something and you need to center it at zero, right? That's what our brains are essentially doing when it comes to resetting, recalibrating our zero line for temperatures. What's normal? What's normal today is different from what was normal from a statistical perspective 30 or 40 years ago. And our brains do that adjustment. There's actually good evidence that humans, at least psychologically, make that adjustment internally, and they really only notice departures in temperatures over periods. They have about a 3 to 5 year time horizon. If today's temperatures or this year's temperatures are not that unusual compared to the last 3 to 5 years, people don't perceive it as being highly anomalous, even if it was literally warmer than any temperature that had occurred in their entire lives prior to those 3 to 5 years most recent. So which leads to an interesting conundrum, because it means that because warming is never linear in any given place, and there are plateaus of warming as we sort of stair step upward, during one of those plateau periods, even a relatively cool spell in the present context, which would have been exceptionally warm 50 years ago, feels really cold. People don't perceive that period to be warmer than it would have been, even though it is. And on a certain level, right, that might be good news. To the extent that we can adapt to climate change, the less that we notice it's happening, and some might argue, the better, right, because it's suggestive of impacts not being as great. But the problem with that argument is that it doesn't really account for all the other stuff that's going on. It may well be that we don't really perceive temperatures being 3, 4, 5 degrees warmer today, Fahrenheit over land, as really being noticeably different from the past. But the Earth's climate system, again, certainly knows this, and as I've talked about before, the atmosphere is responding in kind with increases in the vapor holding potential of the atmosphere, for example, by 3 or 4% per degree Fahrenheit of warming. So once you have several degrees of warming, that's not a small change in the ceiling on both how intense precipitation can become on the one hand and how intense evaporation can become on the other. But also, just because our brains now perceive it as normal does not necessarily mean that our human physiology does. So imagine during an extreme heat wave, if historically 50, 60 years ago, if a heat wave might have been 105 degrees and today it's 111, it doesn't necessarily mean that our human bodies are better adapted to that, particularly as we get into places that experience hot and humid heat that are close to the upper limit of physiologic tolerance. So there is a combination of heat and humidity, usually described using the wet bulb temperature. The term is wet bulb temperature. And that's a fairly hard upper limit on what humans can endure without active cooling, so essentially without air conditioning. I won't talk too much about that today, but my point is that there are intrinsic thresholds. There are some plants that can only tolerate a particular level of sustained water stress or evaporative demand or extreme temperature without having some major problems. Can we adapt crops that are grown? Sure. This select through selective breeding and genetic engineering and all sorts of things that can shift the properties of individual plant species to be more tolerant of whatever today's conditions are in a variety of settings. But that's not true at all of plants in the environment. So a forest standing today, for example, that was there 100 years ago, that was there 1,000 years ago, it doesn't have the magic ability to change the species that are there overnight. So even though our brains think that, okay, well, this isn't unusual relative to the last 3 or 5 years, so we're okay, our own internal physiology hasn't necessarily made that shift. The natural environment can't make the shift nearly that quickly, and even our built environment hasn't made that shift. Think about all the dams in California. When were they designed and when were they built? Certainly not in the last 30 years in almost all cases. And so we're sort of stuck with the legacy of the past in terms of our infrastructure, in terms of literally evolution biologically, and also evolution and adaptation more figuratively. And so the fact that our brains adjust quickly to our new normal is a bit of a problem because it suggests that we've more successfully adapted to a lot of these things at a societal scale than is actually the case. So increasingly what really happens is we're more and more out of equilibrium with that new normal, with that new baseline, which is ever shifting. We get used to that baseline and then it shifts upward again, or downward again, as the case may be for different variables. But I just thought that was an interesting aside as well, because I often receive, whenever it is chilly in California for a few weeks, many emails from folks saying that I've never experienced conditions as cold in my life. And it's possible in some cases that's actually true. It depends on how old you are and how long you've lived in California. But I think the bigger picture is, well, even if you've lived in California for decades, all of your life, even that isn't enough to tell us about the broader context. All right, enough about that. I did want to talk a little bit about the weather coming in for this weekend again. And as I mentioned, it's another cold low that I can't currently show you. Let me actually just try this one more time. I'm going to spend like 10 seconds trying to get this to work. And then if it doesn't, I'm officially giving up here because it's not doing what I was hoping it would do. Nope, still not working, so I'm not going to waste any more time on it. But another system this weekend coming in, it's going to be fairly cold air aloft. Nothing extraordinary, but, cold air for, I guess it'll be May by then, so for the very beginning of May. whenever we have a system with air aloft that cold this time of year, there's almost always at least some isolated thunderstorms. And given the time of year, an isolated severe thunderstorm could potentially pop up in one of the usual suspect areas, usually like the Central Valley, but occasionally somewhere else. That's because thunderstorms, and especially stronger ones, thrive off of atmospheric instability. So steep lapse rates being the rate at which temperature decreases with height, and so steep meaning a rapid decrease in temperature with height. As you imagine, if it's the difference in temperature between the surface and some upper level of the atmosphere that matters, you can kind of increase that lapse rate in one or two ways. Well, in one of two ways, or in some combination of both, I should say. You can either warm the surface by a lot and keep the upper level temperatures the same, so the difference between the surface and aloft is greater because you've warmed the surface and the temperatures aloft are just as cold as they always were. Or you can cool temperatures aloft and keep surface temperatures about the same. That too will increase the lapse rate. Or, of course, you could do both. You could warm the surface and cool temperatures aloft. This is often what happens during big severe thunderstorm and tornado outbreaks in the Great Plains. In California, it's usually a bit less dramatic, but right now, what will probably happen with the system this weekend, with many spring-like systems generally that produce showers and isolated thunderstorms, is that it's mainly cold air aloft. So the temperatures of the surface get a little bit cooler, but not much cooler, but the decrease in temperatures aloft are much greater than the decrease in temperatures at the surface, and so the lapse rate increases. The lapse rate, that vertical rate of temperature decrease with height, again, the stronger it is, the greater the atmospheric instability, is not the only question at play. You still need some other ingredients to come along for thunderstorms. You still need some moisture to work with in the atmosphere, of course, to create those clouds and to further increase the buoyancy of air parcels that rise spontaneously through the atmosphere and form those cauliflower-like cumulus and cumulonimbus clouds. But you also often need some force to give that atmospheric air parcel an initial kick upward. So unless it's really unstable, usually it's not enough for the air to just start rising by itself. You gotta get it going, at least initially, with some kick in a what's known as a conditionally unstable atmosphere. In other words, it's unstable, but it's not so unstable that it will spontaneously rise into thunderstorms. Something needs to give it an initial lift to allow that air to continue to rise on its own. And the most common way to do that is topography. So in the actual mountains, this is why we often see showers and sometimes thunderstorms form more readily over the hills and mountains than over the valleys, or some sort of atmospheric feature that focuses upward vertical motion. So a boundary like a front, or some other sort of feature, upper level lift in the atmosphere coming from like a low pressure system or something that forces the air to rise, cool and condense, and then can give rise. So in events like this, the cooler the air aloft, even if there's not a lot of moisture, even if there's not much of a strong cold front, you can still get occasional thunderstorms just because the air mass is so darn cold at the upper levels that temperature differential between the surface and the upper levels can result in some thunderstorms. So if we do get some isolated thunderstorms this weekend, there could once again be some heavy downpours, some hail even at the surface, because of course at the surface hail can fall at temperatures well above freezing because these are giant ice balls that are forming way up in the clouds where it's always well below freezing. And as I've used the analogy more than once before, imagine if someone pulls a few ice cubes out of the freezer and throws them across the room at you. Those ice cubes are not going to fully melt before they hit you, so beware. It's the same idea in a thunderstorm. If it's a cold, dense ice cube, which is effectively what a hailstone is, it can travel through a fairly prolonged time in air that's well above freezing. Now, a snowflake, of course, won't do that. Imagine trying to throw individual snowflakes across the room. They're either going to evaporate or melt. They won't. That won't happen. Now, a snowball, of course, is the in between. That's sort of more analogous to a hailstone. Anyway, mixed metaphors there. But in any case, some isolated thunderstorms pretty likely this weekend. More significantly, though, another round of pretty heavy high Sierra snowfall in early May. So over the weekend, could cause some travel problems and some disrupt some hiking plans. So if you're going to be outdoors above 4,000 or 5,000 feet in the mountains in California this weekend, do be aware of the potential for some cold weather and even snow. And that could be pretty decent precipitation in the southern Sierra Nevada, maybe over an inch of liquid equivalent. At the coast, some places will remain completely dry. Other places will see some scattered showers, isolated thunderstorms. Doesn't look like a big deal storm, shifting the needle all that much, although the snowfall in the southern Sierra Nevada will come in exactly the part of the state where the snowmelt has been really rapid in recent weeks. So this will attenuate that and maybe even add a little bit of SWE, snow water equivalent, to pump up those numbers a little bit again before they start to decline again later next week. All right, so I think that covers most of what I wanted to cover. Again, I'm sorry I can't show the images right now, but that's just the way that it is. I will try and get this fixed next time. I'll double check. It's been a new problem every single time I've done a live stream lately. It's just a random new unexpected hiccup. So anyway, the last thing I wanted to cover today, and then I will dive into the questions, again, trying to keep this in within the hour, is a bit of a federal update. My last session was fully devoted to it. It was a long one, so if you're interested in the bigger picture, please check that out, the last live stream. Also out today is an interview turned into a blog post with the Public Policy Institute of California, in which I talk about just how important the National Weather Service and NOAA are for California specifically in the weather, water, wildfire worlds and beyond, and what's at stake if even some of these critical life-saving and economy bolstering services are lost, as is currently at risk. So check that out, the Public Policy Institute of California blog post out today. Also shared it on social media platforms, so you can also find it there. One of the big updates from this week and last is that, first of all, is that the National Science Foundation, NSF, has started purging hundreds and potentially thousands of grants from the system, including projects that were already underway and had been contracts that had already been signed. And so this means that there's a lot of science that was either going to happen or already underway that has officially now been canceled. And at this point, even if those grants were reinstated, most of that science would remain canceled because people have already been let go. People have already had to move back to their home countries. So a lot of the things we're seeing now are starting to become increasingly irreversible, at least in the short to medium term. That's at NSF. We talked last time about the existential level cuts that may still be coming for the rest of NOAA and NASA as it relates to Earth and climate research. That is very much still on the docket. We don't know exactly what's going to happen. There are rumors that some of this is going to go forward this week, so perhaps there'll be more to talk about next time. But that continues to be a great concern, and despite some temporary reversals we've seen, one success, by the way, was the temporary restoration of funding for the regional climate sensors, including the Western Regional Climate Center. After a multi-day outage, that contract was temporarily renewed, which is great news in the short term. But I don't think folks should celebrate too prematurely because it's still very much on the chopping block as soon as later this year once again. So this was a very temporary reprieve, and it's going to take a lot of effort and public pressure to maintain those regional climate centers because they are very much something that could just go away entirely still, sooner rather than later. And again, this is data that I show almost every live stream that I would not be able to show, for example, if those go away. The other thing that happened this week is that there's already been some big changes to the National Climate Assessment and the Global Change Research Program in the U.S. in recent weeks and months since the change in administration. But this week, the much bigger announcement was that all of the upcoming National Climate Assessment authors had been relieved of their duties. And again, this is not a paid position. These are all volunteer roles, so they're not costing the federal government money to do these services. They were providing them for free as part of their public service. Mostly these are folks at universities. All of them were notified this week via email that their services were no longer needed because the report, as it historically had been, no longer aligns with federal priorities. Now, keep in mind that the National Climate Assessment is a congressionally mandated report, so legally, there's still supposed to be a report, regardless of who's writing it or how much actual effort goes into it. So there's a real question now that both the administrative support team and now, even more consequentially, all of the scientists who actually contributed the substance to it, all of them are now gone. All of them, 100% loss. And yet Congress still has mandated that this report go forward, unless that changes. So now there's a question of how that's going to work. If there's nobody available, no scientists available that have been working on it for years to contribute substantive science to the report and coordinate things, okay, how is this going to happen? And there are no clear answers on that, but there are credible, I hesitate to call them rumors, because these, again, as everything else in this process, it's been written down and explicated pretty clearly, that there's going to be an effort to create what would effectively be a sham report. A national climate assessment with an explicit aim of demonstrating how good climate change is for the world, how beneficial global warming is for Americans, all the benefits that melting ice sheets and increasingly severe wildfires and severe heat waves bring to the American people, apparently. That's not set in stone. There's no document, federally that you can point to where that's the explicit goal, but there have been on and off the record comments by various officials saying they want to, quote, red team the National Climate Assessment, which effectively means finding highly partisan sycophants to come in and make a ideological argument rather than a scientific one. That would be pretty devastating turn of events to have a national climate assessment which is not just useless but actively harmful. And so I sincerely hope we don't go in that direction. But it is a distinct possibility, given that everybody who actually has background in weather and climate and Earth systems and the carbon cycle appears to have been released from producing this report. And to the extent that it is congressionally mandated that a report be materialized in the next few years, there has been a stated goal of writing one that comes to a preordained conclusion that climate change is good for us, which all available evidence suggests is simply false. So there are various words to describe what it is when you deliberately create something that you know isn't true, but I'll leave those descriptions to others for the moment. So that's the federal update of the week. It's a lot of things are right now in a bit of a holding pattern until the next shoe drops, but unfortunately, there's every indication that additional shoes will drop. So that's sort of where we are right now, and when there's a next big one, I'll try and have another session dedicated to it as well. So I did want to leave 10 minutes to answer some questions, which I will do now. So if you have questions and haven't asked them yet, now would be a good time to add them to the chat on the topics that I've been discussing today. It's a good opportunity because there aren't too many comments today. So my likelihood of seeing and responding to yours is slightly higher than average, I would say. There's a comment from Patrick from Bremerton, Washington, that there's substantially below average precipitation for this year in the Pacific Northwest. And as it turns out, yes, it was a pretty good start to the season last fall, but the numbers decline. There actually is a patch of moderate drought now in Washington. So depending on how the spring and early summer goes, this could be part of the wildfire story this summer, is that there could be pockets of the Pacific Northwest that start to see much more active wildfire conditions earlier even than parts of Northern California, because in relative terms, parts of Northern and Interior California were wetter this past season than were parts of the Pacific Northwest. Not necessarily in absolute terms, but the atmospheric river corridor was repeatedly focused on that northern third of California and that southern third of Oregon, at the expense of both Southern California and also at the expense of parts of the Pacific Northwest further north. It's a question from Puma Mountain Lion. Is the cooler May and spring temperature related to the evaporative cooling phenomena, where due to a wet landscape earlier in the season, which absorbs excessive heat? That's a good question. It is true that the land surface can greatly modify, in particular, heat waves, but also just temperatures in general, by shifting the partitioning of heating from sensible heating, meaning literally sensible, heat that you can sense or feel, meaning like an actual increase in the air temperature, as opposed to latent heating. Latent heating being in this case, the heating that goes into increasing the temperature of water stored in soils or evaporating the water that is in soils, and that can be considerable. So imagine, for example, in a thought experiment, two very different examples. One, a very large expanse of bare dirt that is bone dry, and then you have a heat wave, strong sun, no clouds, no rain for weeks. Well, that heat wave is going to be more intense because more of the sun's energy can go into heating the actual soil, and thereby heating the lower atmosphere, so the actual air temperatures, where we're standing near the surface. But if that same vast patch of dirt were very damp instead, had a lot of moisture, or even puddles, say, as is the case in some spots this time of year, before that solar energy goes into heating the air, by heating the ground surface below it, it's first going to have to put in a ton of energy to evaporate that water. So until that soil column, until those puddles are evaporated, and until the water on the surface soil is largely depleted, a lot of that energy from the sun is instead going to go to evaporating water rather than increasing the temperature of the air. So more of that heating is going into latent processes rather than sensible processes. And so yes, there is an element of that. Is that what's going on right now? I don't really think that's a big part of the picture, but it could be important locally in places that are a bit wetter than expected. Latent versus sensible heating, by the way, is a process that is simulated in seasonal climate models to a certain extent, to varying degrees depending on the model and the land surface processes that are represented in it. So it is also true that despite the fact this is a process that exists in models, it's not always one that's perfectly well represented. It's also the case that anywhere that's wetter than expected in the real world, relative to the model world, might see more of this kind of partitioning. So it's a good question, it's a good intuition. It might even be at least a small part of what's happening, although I think the bigger part of what's happening has more to do with the large-scale flow and the relatively what's called a progressive weather pattern. In other words, the alternation of ridges and troughs, rather than either being persistently ridgy or troughy, if you will. We may see more of the persistent ridging as we get later into May and the summer, but right now we're not seeing that yet. So I think that's largely what's helped, but maybe this latent versus sensible partitioning being another piece of it as well. Yeah, Eric Fielding mentions, I have lived in California for most of the last 30 years, and so I understand that this is my baseline. And I think that's, from a perspective of folks who study earth science, I think a lot of them tend to have that intuition that, your recent experience is not necessarily a fully representative one more broadly in space and time. But even within that 30-year period, it's worth noting that just in the last 15 years, California has seen 2 historically severe droughts and most of its hottest years on record. So not only has the climate been non-stationary, but it's also been really skewed even to the last 30 years, just over the last 10 or 15 years. So food for thought there too. Question from Darius, can you talk about the potential of an early start to the monsoon season, and will the Eastern Pacific Ocean see active hurricane season or average? Well, Well, we don't expect to see either strong El Nino or La Nina conditions this summer, so it's a little harder to predict the Eastern Pacific hurricane season because that's one of the stronger modulators of that. So I don't really have a strong inclination either way about the Eastern Pacific hurricane season. As for the monsoon, there are some hints in the models that it could be a decent monsoon year, at least across the interior Southwest. So there aren't really strong signals of a poor monsoon this year. Now, to be clear, monsoon predictions are really difficult, more difficult than outlooks of temperature and humidity for the summer months for a variety of reasons. And so that's something that I wouldn't take particularly seriously. But there is a slight tilt in the odds towards actually an above average monsoon year this year. Now, are those predictions highly skillful? Not really. All precipitation is always much harder than temperature at that kind of lead time. But on the other hand, there aren't any signs of a particularly poor monsoon this year either. So that could be relatively good news, but again, we don't have great monsoon predictions. It still looks like the summer will be an exceptionally hot one across most of the West, including much of California, and that much is a little easier to predict. But we will see. The things have not gone quite exactly according to plan over the last couple of months, so we will see if that continues. There's a question about what exactly is the specific definition of temperatures of the surface and temperatures aloft. What is the elevation marker? There isn't really a specific one. In fact, the different levels sort of matter in different contexts for different reasons. But often we'll talk about things like the surface to 850 millibars. And 850 millibars in the context of atmospheric science is like a vertical coordinate. So you can convert that to a number of feet or meters above the ground. Often we use pressure coordinates because it's for a variety of mathematically convenient reasons, essentially. But in any case, it's often the bottom 5 to 8,000 feet of the atmosphere where we think a lot about the vertical temperature differential. That gets us up to, maybe at the upper end, 700, 650 millibars, something like that. Usually we care about temperatures below the 500 millibar surface. So the 500 millibar surface is essentially the half mass level of the atmosphere, where half of the air mass is below and half of it is above. But even more specifically, we're often interested in that temperature differential in the very lowest levels of the atmosphere, so the bottom few thousand feet or so. Not always, and you can get what's known as elevated convection. So when we see those dry thunderstorms in summer, often there'll be like a relatively thin 10,000 foot layer above the surface, maybe between like 10 and 20 or 15 and 25,000 feet up, that is unstable. And the surface could even be very stable. Sometimes we've seen dry lightning on top of coastal fog, for example. Bit of a story for another day. The answer is it really varies. But surface usually means pretty close to the surface. Like, I'm leaving my hand in the surface layer, Jen asks, how likely is it for Southern California to have a hotter than average summer, especially across inland areas? Very, very likely. Coastal areas, I actually think more likely this year than the last couple of years, which have not been particularly warm right along the coast. Again, I wouldn't read too much into May or even June in Southern California, the May and June loon season. The real question is what happens from July through September or October, and those do look particularly favorable for unusually hot conditions, especially across inland areas, but maybe closer to the coast this year than last year. All right. Well, a few other questions that I won't have time to answer today, but there is one more I wanted to answer here because it's actually related to, and thank you for reminding me, one other thing I wanted to talk about today in the federal update. Do you know from HJW if there are any updates to the firefighting personnel that got cut or downsized early on in the administration. Really worried about fire season and our ability to fight it in California. Well, first of all, in California, there's multiple levels of wildland firefighting that are available. Cal Fire, being a state agency, is largely independent of federal funding, and so it has not been subject to the whims of the current presidential administration to nearly the same extent. But there's also county and regional fire crews, and even some city fire crews, as we saw in Los Angeles, that have wildland fire capability to some extent or another. So California is better off in some places because there are multiple layers. But then again, California also has a tremendous amount of federal land, and the Forest Service would be the main agency involved in wildland firefighting on those federal lands. That's not exclusively true. There's also wildland firefighting capacity within the NPS, the National Park Service, the BLM, the Bureau of Land Management, within the Department of Interior. So there's some other smaller wildland firefighting capacity as well. But on the federal side, it's mainly through the Forest Service, which is in turn part of the U.S. Department of Agriculture. And there have been major cuts to the Forest Service. And this is where I think reading between the lines a little bit is important. Initially, there were hiring freezes and even firings of actual wildland firefighting positions, which was very concerning and demoralizing and caused some big problems. That ended, that was reversed, and the Forest Service is now claiming that they have now hired back a lot of the people who were fired, and that the Forest Service is now actively hiring because they fired some people earlier this year in those roles, and because there had been a hiring freeze during the time of year when they normally would start hiring seasonal wildland firefighters, because a lot of these roles are seasonal. It's not a full year job, historically aligned more with Western fire season. So in some cases, they are actively hiring, actually, firefighters, but they're behind the curve, and these crews are understaffed. There's been an understaffing problem in recent years due to very high occupational hazards and low pay, so it's become a harder job to justify for a lot of folks, I think. There was a modest but meaningful improvement in pay this year that was implemented, which will help a little bit, but still there is understaffing, even though there's active hiring going on. But the part I really wanted to emphasize is this. Even though it may well be true that the staffing was restored for actual wildland firefighting roles, a majority of the people in the federal workforce who actually go out on fires do not have the word firefighter or the title forestry technician in the same way in their job title. So they might have not been hired on to be firefighters per se, but they have what's known as a red card. So these are federal employees, especially the Forest Service, but also some other employees who are trained in wildland firefighting procedures and techniques and safety. And so they are credentialed, essentially, to be deployed on fires when and where they do occur, and to work alongside the dedicated wildland firefighting crews. There's thousands of people with these kinds of roles in the federal government, or at least there used to be. So that's a significant portion of the National Wildland Firefighting Force, and within the Forest Service, and a lot of those people were still fired and are actively being fired now. So it's not really giving a complete picture just to say that the wildland firefighting part of the Forest Service, the funding has been restored and they're hiring. That might well be true, but it also misses this other piece, which is pretty concerning. And there are widespread concerns that the large-scale loss of red-carded folks from the federal government might well still cause significant personnel shortages once crews become fully occupied later this summer. We probably won't see that for a while because there's still plenty of crews to go around, although, again, we're still technically in April. That could change in July or August or beyond. So, in California, there's a little bit more insulation because there's other fire crews as well. On the Forest Service side, supposedly the firefighting roles are supposed to be protected, but that ends up being a little sort of a technicality that sort of hides the reality that there actually still were and are a lot of people who would end up on these fires who no longer have these jobs. those red-carded folks. So that's the main update there. So thanks for reminding me to talk about that. Again, apologies for the technical issues with my inability to screen share. I don't really know what's going on there, but I'm going to try and figure it out as soon as I end this session. I guess I'll test it next time before the session. I swear, this time I tested all the audio, all the other things that have gone wrong before, and they were all fine, but the one thing I didn't think to test is, of course, was the weak point. So anyway, thanks for joining. I'll see you next time. Check out, as I mentioned, the blog post if you want more details about some of what I was talking about today. I wrote that just yesterday. Or the PPIC, or Public Policy Institute of California, interview in form of blog posts that came out today on their website talking about the bigger picture surrounding NOAA and the Weather Service and its importance and its critical role in California and beyond. So thanks, as always, for joining, and I'll talk to you next time.